All computer programs, in the end, essentially, are math. Everything we see is a number. Now, there are many ways that a computer can use mathematical numbers or equations to create images that we as human observers see as pictures. We're going to take a look today at how two main programs in the Adobe Creative Cloud, formerly the Creative Suite, but hey, I guess I'm getting kind of old here. How do they use math to define the images that you see on your computer screen? We're going to look at the difference between how Photoshop thinks and how Illustrator thinks. This is Professor Ben Kewitt from Fullerton College's Printing Technology Department, and I hope you'll join me to take a look at a little bit of how these things create imagery. Let's start with Photoshop. I find that most people are more comfortable in Photoshop and more familiar with it, so it can be our starting point for our comparison. Also because when I was a child and I was learning this stuff originally, back when dinosaurs roamed the earth, and it was Photoshop like 1 and 2. But anyways, Photoshop was the first one to really take off, and it's more actually, in a lot of ways, more intuitive to a beginner than Illustrator can be. Although once you understand what Illustrator does, it works a lot better for you. So let's start here. I have to apologize to any advanced users out there who may be watching this because they have added some new tools in Photoshop that maybe I'll talk about at the end, which further, because they've been doing this for a while, further blur the lines between the Adobe programs. Photoshop handles photos. Let's start with a different picture here, actually. Ah, my old friend, the Spitfire Mark 5B. Beautiful, beautiful plane. Anyways, this is a photo of an old airplane. To you, to me, this looks like that great defender of freedom that is the reason there's still a Great Britain. But to the computer, this is a series of 4 spreadsheets. Borrowing a little bit from my favorite mathematician slash author slash comedian, Matt Taylor. Good job out there, Matt. I love your videos and I read your book. Anyways, there's a series of numbers kept in basically a matrix. If any of you have gone through the maths or use matrices, it's just a grid of numbers. So is this picture. If you think about it, not if you think about it, in RGB color, let's open up the color picker for a moment here so we can understand what's going on here. In RGB mode, if you look right down here, you'll notice that any one of the or any part that you pick using the eyedropper tool, once you have it open, you can see the values of the numbers behind. The values are between 0 and 255 for each of those numbers based off of 1 byte of memory being used to control that color's values. It uses the 3 primaries, red, green, and blue, of additive color, which is how computer monitors and anything that beams colored light into your face, like TVs and such, mix color for you to see. They send out light on the wavelengths that your eye's receptors are actually looking for, which might be one of the reasons these things are so addictive to look at, because in the real world, your eye has to cut through a lot of clutter and has to go through the work and the exercise of looking at the landscape in front of you and understanding what all the different things are. But when you see that same landscape photoed onto a computer screen, a cell phone screen, or onto a TV, suddenly it's boiled down into easy data that's simply just what your eye wants to see. And it doesn't have to filter out any of the unwanted bits or make sense of mixed and strange reflecting objects. Oh no, it's all just what you see is what it is. So there you go. It's an underhand pitch so your eyes can hit it easily. Anyways, each one of those things, red, green, and blue, matches one of the receptors in your eyes and mixes to show you color as you would see them. Those numbers between 0 and 255 for red, green, and blue each tell you about how much there is. 0 is all the way off, so that's none of that type of color. And 255 is all of that color, as bright as it goes. If you mix all of them together at full intensity, 255, red, green, and blue, you get white. Because white light, at least as humans see it, white light is equal presence of red, green, and blue light at full intensity. And black is, or darkness is, no light at all. So depending on how much of one of them or the other there is, here I'll click onto a red area. It's not the best red area. Actually, be surprised that not everything is as intense as you think it is. Red is almost 200, but green and blue are both down in the 100s. Now, this grid I'm talking about actually comes out as a physical grid. This is a pixel-based or raster program. What that means is the picture, as you zoom in, you start to notice is made out of little squares. And you zoom in closer and closer and closer, and you can see individual squares. And in fact, Photoshop, to help you out, whoops, will give you a white grid around them to see the edges of the squares. Each square in this is controlled by 3 numbers. One that says how much red light, one that says how much green light, and one that says how much blue light should be seen, also visible in the channel layer down here. Everything you do in Photoshop, no matter how simple or how complicated, all it does is modify the numbers that control each one of those pixels, each one of those little squares of color. Let's now take this and take a look at what happens. If I draw using the older tool, again, there's a new tool available that does things that aren't quite the same and actually blurs it a little bit towards how Illustrator thinks. I'm not going to use that. We'll do an older method. If you take the marquee tool and you draw a rectangle and you take the paint dropper tool, oh, I have no layers selected, whoops. Let's select the layer and we drop. There we go. I've now made a rectangle out of green. If I deselect and zoom in, you can see that this green rectangle is actually made up out of thousands of tiny green squares in a grid. So it looks like a rectangle to your eye because humans see the whole picture, but to the computer, this is a spreadsheet of numbers that say green a lot. Let's see how much it says. It says, oh yeah, give me 118 green, 17 red, and 50 blue in each one of these squares. It's all the same this time, unlike that airplane. Let's do another picture here. Let's take an elliptical marquee and I'll keep it proportional so we have a circle. Let's do the same color again in here. Oof. And now I've drawn a circle next to it. If you zoom in on this, you'll notice the edge of the circle kind of fades a little bit funny because on the edge of a rounded or diagonal object, you can't exactly show a perfect edge when it's made out of pixels. So it kind of blurs the edge a little bit to make it look rounder. That's why even though I only used one color, you now see 3 or more colors of varying, actually four intensities of green as it kind of fades it out to the white. That way the edge doesn't look jagged. It instead looks maybe fuzzy, but at least it's round. The edge of the rectangle wasn't a problem because squares easily stack to make rectangles. You'll also notice now that by putting these things together, it's become one thing. Let me grab the magic wand tool, one of everybody's favorite tools in Photoshop, and select this. And you'll see the little dotted line that tells you what I selected goes around the whole thing. It has become one object because when you put pixels on top of pixels, it makes pixels. Okay, so that's Photoshop. Let's take a pause here and jump over to take a look at the other side. Let's go over to Illustrator and talk about what Illustrator does. Illustrator is very, very different. One of the reasons that Photoshop makes so much sense to people is because, technically speaking, Microsoft Paint and other basic paint applications on computers, the little doodly ones where you wiggle the mouse, you draw shapes, and you click to add patterns and stuff, that is also raster pixel based imagery. So it's very similar controls. Photoshop's just doing a much more impressive job. And when Photoshop does a filter that changes all the colors, well, all it's really doing is adding the same numbers to every single cell in the whole giant picture. Now, when we switch over and we take a look instead at Illustrator, Illustrator does not use pixels to make a picture. Illustrator uses objects, and the objects are defined by mathematical equations. Let's go ahead and do it. We'll take the rectangle tool and we'll draw a rectangle and we'll set the inside as green. Green, I can click, and we will say no outside, please. Cool. Now let's zoom in on this. As you zoom in, you'll notice this green stays green. There's no grid. There's no pixels. If you zoom in all the way, you can't even tell how close you're zoomed. There's an edge where it stops being green and starts being the white of the paper. I know that sounds boring, but bear with me here. Let's also then look. Let's do the second part of the same experiment. Take the ellipse tool. We'll draw roughly the same thing I drew on the other side. And it's also green. And there you go. I now have the same object as we had in Photoshop, albeit the green's a little bit different because I just kind of randomly chose a green over there, and this one's a swatch. Now, when I select these, you'll notice that they're still separate. The rectangle and the circle touch, but they don't connect. If you're used to using Paint or Photoshop, you expect your objects to glue together when you put them together. Don't they always just meld? Well, they don't, because over here, each one of these shapes is its own object, and the computer recognizes that it has corners, 2, 3, 4. It has midpoints, and there are lines that connect the corners. And inside this shape, made out of the corners and the lines that connect them, you have a color filled inside. Same for the circle, except up here, let me cheat and grab a different tool so you can see it. If you select one of these anchor points on here, there's also handles, and the handles control the curvature. When you get more daring and you want to play with the pen tool, the Bezier curve tool lets you create complicated curves by controlling these handles. But as a basic show, if I move one of these, you can see that it is basically has a gravitational pull on the line below it, and it is drawing it out and pulling it towards itself. So these two objects stay separate, and they stay unique. These two things together can be grouped, or they can be glued together using the Pathfinder tool. Anyways, that's the big difference. Illustrator really wants paths, which are those lines, and points to complete, to make an object. And when you go back to edit it, you're editing object by object. If I want to change the color here, I make one, whoops, I had the outside selected, sorry guys. I make mistakes too. If I select that and I hit yellow, it's now a yellow circle. If I want this to be yellow, I have to select it and make it yellow as well. These two objects are separate. And let me show you one last thing here, because when we zoomed in on when we zoomed in on Photoshop, you got to see those pixel edges to know the difference between the two programs. But over here in Illustrator, let's do it by looking at outline instead of using the CPU view. Outline will show you what Illustrator is actually thinking. Here we go. When you look at outline, this is what your design is actually made out of. It's made out of multiple objects consisting of points and lines. Each one of these is a separate object to the computer until you tell it otherwise. By the way, it's still there. If I click on one, you can see the things. And if I go and turn it back to view using CPU, whoops. Oh, GPU versus CPU. View using preview instead, sorry, preview, and I said the wrong thing. Preview versus outline. The preview shows you the color because it also assigns a color to what you put inside. So that's the difference. Photoshop builds an image made out of pixels. To the computer, it doesn't look like a picture. It just looks like a giant spreadsheet full of numbers. Meanwhile, Illustrator shows you objects that make a picture when you look at them, but to the computer, it's simply mathematical formulas that define the shapes, sizes, and angles of these lines. We can also take a quick look, because I have a minute or two left on this one, at how they handle text. Now, typefaces on a computer are by nature vector information. Vector is the computer word for these lines with points and shapes. These shapes made out of points and lines. That's vector. Vector text. I know this is just the default myriad, and unless you're doing a certain coffee company, you don't necessarily need this typeface, but there it is. When it's still text, Illustrator sees this as a baseline. You can see underneath here that the words are being written on when it's still considered a font. If you convert this to outline, the text then becomes how it actually is. It becomes shapes. Actually, let's go back here and see the outline. Text is made out of vector information that's swapped in as you type. Once you outline it, it converts only to this. Let's jump back over and take a quick look again at our friend Photoshop. Oops, wrong font here. Make it the same. Myriad Pro regular, there we are. I know it's called caps. Raster text, I made it small on purpose. Even though you're typing, Photoshop knows that this is going to be turned into pixels. So small text on Photoshop is going to have the same problems we saw like with the edge of that circle. Let's go back here and look at the edge of the curve on that R. Because it can't show the exact edge with a pixel, the edge goes between pixels, it gives you pixels of between values. If a pixel gets cut in half by an edge, it shows you the average of the two sides as the edge. You can even see that on the vertical part of the T, because the width is not precisely a pixel, it has that shadow. If I make this text bigger, it actually becomes a little bit cleaner because you're able to have more pixel information in it. In fact, it even shows you below about how much is being used. Now you can see it's a little bit cleaner. It still has the weirdness of the gray areas around the edges, but it's a little more solid. So that's raster text. If you zoom out far enough, it'll look fine to you, the human, but the computer over here is using it as pixels to make those words. Anyways, that's the big difference between the two programs. Photoshop builds everything out of little tiny squares, kind of like Lego bricks, and Illustrator draws them basically kind of like drafting, like a computer-aided drafting program. It figures out where things should start, where they should end, and how they should connect. Thank you for listening. I hope this was helpful. Stay tuned for more information on the channel as we explore further into design and print.